like to start out by welcoming everybody for joining us this evening, this morning, wherever time it may be where you're located. My name, as Heather said, is Jeff Bonkoski. I'm the Western Area Manager with Hazard Control Technologies. I am a retired firefighter from up in Michigan, just south of the city of Detroit. I 27 years as a career firefighter, and yeah, I'm still working with volunteers and doing training and things like that. So I'm 30 plus years total in the fire service. While I was working, I trained to the level of a hazmat specialist. I was also a paramedic and trained to a tox medic. And through my career, basically, I was out trying to find solutions for some of the difficult and hazardous fires that firefighters face on a daily basis, and trying to make the profession safer. And doing some consulting work after retiring, started to search for a solution and to try to make and help firefighters deal with these fires in a safer manner. By doing so, I came to Hazard Control Technologies, and we're going to talk a little bit about Encapsulator Agent and how it does just that. And tonight we're going to be talking about the spill control and spills and flammable liquids and things. I may kind of drift off and cover a few things that we also work on, but we'll try to see if we can't somewhat stay on track. So again, welcome. As we go through at the end, we'll open things up for questions. So by all means, feel free to be prepared to ask questions when we get finished with this. To start with, Hazard Control Technologies' mission is to, as we say, encapsulate the world and trying to make it a safer place through the leadership in fire prevention, protection, and suppression. And as we say, using that eco-friendly, innovative technology. We sit there, you look at where we're from. It's Atlanta, Georgia is where our home office is. And as it shows, we have a fluorine-free solution product, encapsulator technology, that works in engineered systems with emergency response. We also work with training and consulting. And again, as we show, we're worldwide distribution with offices throughout the world in North America, South America, Africa, Asia. We try to, as we say, work to encapsulate the world. Some of the important things are in doing and trying to be active in making firefighting a safe profession, is also being active in many different committees and technical groups and so on and so forth. So we are members of the NFPA. We have members that sit on technical committees. We're also contributors to the IFSTA manual with fire training and Society of Fire Protection Engineers. And we are very proud of the fact that we are an ISO 9001 registered company. Quality control is very, very important to us. So as we sit there, we start looking, as I mentioned, with the new hazards that we're faced with, and you know, the difficulties that we have with some of these fires, because with the new materials are growing faster. We also look at, you know, some of the things that are contributing to that. Lithium-ion batteries, you know, that fail and, you know, while they're charging and can start some of these fires. We'll see here as we go through and we start talking about those flammable liquids, the three-dimensional fires. Okay, and understanding that when we look at the NFPA 11 foam standard, if we go into Annex A11 of the standard, it even states that foams are not suitable for a three-dimensional flowing liquid fuel fire or gas vapors. So up to now in the fire service, the only thing that we've really understood has been water and foam. So hopefully as I go through this presentation, I'll give you another tool for your toolbox and help you understand how Encapsulator Agent can help you with those. The others is the Class D metals, the magnesiums and the titaniums, and all the different applications that these types of metals are being used in now because they're lighter weight and stronger. So like I say, in order to make a car a little bit stronger and lighter weight, we're seeing about an average of about 380 pounds of magnesium in an average car. And then we sit there and not only do we have the lithium ion batteries, but the solar panels with all these homeowners that want to try to be off the grid, or in remote locations, camping and things like that. They want to be able to charge their phones. We're seeing solar panels popping up all over. But today, again, I want to kind of concentrate on that spill control and hopefully give you some ideas of the features that encapsulator agent brings, the applications, and the advantages when it's used in spill control, and the economic comparisons that we might have between what we're used to using and how we're used to using things versus encapsulator. So we'll be talking a little bit about the differences and how we are different than a foam. Where foam makes a bubble, you're going to hear me talk a lot about spherical micelles, and hopefully when we get done, you'll have a better understanding of what a spherical micelle is, how we are able to properly apply encapsulator agents so that they are very effective and they work for us without having to use up more than required, and then identify different types of emergencies where encapsulator agents can be used. So to start with, the question may come up, what is an encapsulator agent? Well, encapsulator agents, as we see, we started out with Hazard Controls in '96 that acquired the patent rights to a water additive, and they found that it had some effects on Class A, B, D, and fires, and most recently now we find out that we also have a very, very big effect on being able to extinguish lithium-ion batteries, as well as now, as I mentioned, the three-dimensional fires. And it works not only on hydrocarbons, but it also works on the polar solvents, ethanols, alcohols, and the different things in the polar solvent family. So it's this new technology, and it's covered under NFPA 18A. So we do fall into a standard. It's a standard on water additives for fire control and vapor mitigation, and it was recently updated. And here is I show the 2022 edition. In this 2022 edition, right now, I believe it is the only standard with NFPA that has annex material that speaks about the use of an agent on lithium-ion batteries for fire control. So we are now in a standard that can address some of those problems that we may have. Within this standard is Section 7.7. The standard is a test, a minimum test that we go through that shows that we create spherical micelles that are stable in the presence of high heat. So this test is a way to evaluate in 7.7 how that additive F500 is able to render hydrocarbon fuels non-flammable through encapsulation. And we'll talk more as we get into this a little bit more. So as I mentioned, our basic building block is a spherical micelle. It's not a bubble. It's not foam. Where foams work as a separation between the fuel and the oxygen on a mechanical basis. Okay, we start looking at how a spherical micelle works. Now we're doing that separation of fuel and oxygen on a chemical molecular basis by encapsulating. And we'll understand that hopefully as we go through in another video. In order to really understand how that's accomplished, is a real quick video.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart, The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So these spherical micelles yet inside of each and every drop, water droplet, are and will perform a function, as we'll see. They're very important, but this skin on the surface that we put on the water droplet, if you watched any of our other presentations, you understand that that skin that we put on the surface actually changes the way that water droplet is able to cool and extinguish fires without the creation of heat. This presentation is on spill control, so now we're going to talk a little bit more about what these spherical micelles within each and every water droplet are going to do. To give you a visual of an idea of how many of those spherical micelles are within a water droplet, we came up with this as to help you come up and visualize. If that water droplet was the size of the Earth, okay, a spherical micelle would be the equivalent to about the size of a pea. So just imagine how many peas you can stick inside the Earth. There's quite a few. So there's millions and millions and millions of these spherical micelles within each and every water droplet, and what they're going to do and help us with when we start dealing with different types of situations, fires, soil remediation, spills, and things, is it's going to help as far as any rapid cooling. If we have some type of an ignition source, something that's heating up, that could possibly cause or create a fire situation around flammable vapors or flammable liquids, we can cool those sources. We can cool those ignition sources. We can encapsulate those fuels and reduce the toxins that are being released when fuels are being burned. And everybody today is looking for that fluorine-free solution. F500 is that solution. We are fluorine-free. We've been tested by an EPA-approved lab, and it was actually tested for 25 different fluorinated ingredients. The results came back that we had 0 of the 25 that were tested for. So when we sit there and start looking at these droplets and how rapidly they reduce heat, again, think about those tails that were on the surface of the water droplet. Those tails act like a heat sink. They drive the heat inside of the water droplet where those millions and millions of spherical micelles are. Those spherical micelles within the droplet rapidly absorb the heat, slowly releasing the heat into the water that's around it. But through that process, that water never reaches 212 degrees or it creates steam. So there's no longer those issues of firefighters getting steam burns and some of the other, or if we have victims within structures, them getting steam burns as well. So it also, because we're able to cool, as I mentioned, if you have a tank truck fire, if you have a fire at some type of a facility where you've got sources that will absorb and hold the heat for periods of time, until that heat is dropped down below auto ignition temperatures, you're going to have that constant worry of a reignition of those liquids until you get down below that auto ignition temperature. So what we're going to do here now is we're going to talk a little bit about that 7.7, that spherical micelle stability test, and how it's able to reduce the risk of ignition. We need to understand when we see this test, there is a formula. Okay, there is a guideline that we have. It's 1 part of F500 encapsulator agent, 8 parts of fuel, and a minimum of 40 parts of water, or a 1:5 ratio. It also, if we want to look at the solution, it's a 2.5% solution. When we look at most of our fire apparatus, our inline eductors, our proportioners, they usually go to 3%. So there's a bit of a safety margin in there. The kinetic energy is going to be that water splashing on the ground as we're trying to maybe treat an area that may have encountered a spill. We're treating the ground. The kinetic energy is going to be a requirement. And as we see here in this video, This is the spherical micelle stability test. And each and every batch of our product before it gets paled goes through this test. This is the NFPA 18A77 test, and we start with a gallon of a flammable liquid, gas, diesel, jet fuel, whatever, fuel that we want to test with. We use 16 ounces of encapsulator agent, and we pour that into the pan, and then we will measure out 5 gallons of gasoline, or excuse me, 5 gallons of water. The kinetic energy that I mentioned earlier is going to be that water that we add as we are timing. The kinetic energy is the water splashing into the pan, and as we can see, we kind of use it to mix it up. So that gives us that kinetic energy that we need to cause and to help with the encapsulation. So he's going to time this out for the 5 minutes. I'm going to speed this up just a little bit. As you can see, there is a milky white discoloration to the water. There's not a lot of bubbles because we don't work on that basis. We work on, again, a chemical molecular basis, not a mechanical basis, making foam bubbles. After he adds the water, though, because there could be some minor frothing, some small little bubbles that might form in the process of adding the water, the solution is allowed to set now for 1 minute. And at the end of the 1 minute, we'll take a torch, and the torch will be passed across the entire surface of the pan, and there can be no ignition. So as you can see, we're getting the torch, going to dry a little spot there to show the torch is working. Torch is passed across the entire surface. There can be no flames. Now, where this becomes different than foam, and we'll see as we go through and speed it up here just a little bit more. If this were foam, in a course of a few minutes, the bubbles would start to dissipate, the blanket would break down, and you would have to do a reapplication in order to keep that blanket so that you're suppressing the vapors. This has encapsulated the fuel. So now, as part of the test, that pan needs to sit for 2 hours. Okay, at the end of 2 hours, they will again take the torch and pass the torch across the entire surface of the pan. Okay, and throughout that second test, there can still be no visible flames. And I will tell you that, as long as that is not put into a sealed container, as that pan were to sit just like it is right there in the open, there would be no visible flames from that solution that's been encapsulated. That gasoline is now no longer a flammable hazard. We talk about, because people say, well, that works as far as the gasoline, but testing has also proven that we're able to reduce the toxins and the soot and smoke, the carcinogens, as well as with lithium ion battery, the hydrogen fluoride gas that's released when those batteries burn as well. So this encapsulation process not only works on the fuel, but also in that black smoke, reducing the soot, the carbons, and having a great effect in improving air quality and visibility while reducing those cancer risk. And we sit there and we start looking at our firefighter trade magazines and everything. We know that we have lawyers looking for basically clients in the fire service and all around that have been exposed to our current foams and things that may have been a cancer causing agent that we've been exposed to through our careers. Now, when we sit there and we start talking about that ability of an encapsulator agent to reduce those carcinogens. It's based on a Clemson University study. And what was done is they took an inverted glass funnel and they ran a series of tests using toluene as the fuel source, spraying plain water through the hood into the smoke column. They weren't trying to extinguish the fire. They were just spraying this water into the smoke column. And again, they did a series of tests, and then they did a series of tests using a 3% solution of F500 encapsulator agent. Again, spraying through the smoke column, not trying to extinguish the fire. They found from the use of F500 that they were able to improve visibility by 68%. The accumulation of the soot was reduced by 97%. But where the carcinogens are, the toxins, the things that are killing firefighters and having an effect and causing us to evacuate down with 98.6% reduction in the toxins, which is huge. I know of no other agent that we use in the fire service that can sit there and show us these types of results and trying to reduce the toxins and the things that we're exposed to. So all the things in the fire service that we're currently doing, you know, our second set of turnout gear, our particulate hoods and all the other things, we're being reactive to a problem instead of proactive, where we can sit there and now look at an encapsulator agent. Okay, why aren't we being proactive in reducing our exposure to these toxins and these products of combustion as we're entering into these structures? So as I go on, you know, we sit there and we look at F500, EA extinguishes all classes of fires. You know, the A fires, the B, the D. And let me say, it's when I say B, it's 2-dimensional and 3-dimensional. And again, I throw out that foam annex A11 stating foam cannot work on those 3-dimensional fires. The other problem is the current foams, the fluorinated ingredients. They're not only dangerous to the firefighters, but also to the environment. And I know there's many states that have banned their use. They've done buybacks from the fire departments to get them to stop. Some states are treating the use of any incident that might involve the use of a Class B foam almost like a hazmat incident, where if you use the foam, you need to write up a report. The report needs to go to the State Department of Natural Resources, and it may have to go to the health department. They're keeping track of this, I'm thinking, for multiple reasons. And one of them maybe is if, let's say, that Class B foam gets onto some private property, and years down the road, maybe there's some even more strict requirements that come about, and now they find out that that private property is contaminated and needs to be cleaned up. Who do you think is going to be the one responsible for those cleanup costs? It's going to be the fire department that generated or caused that contamination. So we need to not only think about today, but we need to think about the future as we continue to use these fluorinated foams on some incidents that we're being called to. So the applications, when we look at encapsulator agents, are basically all the different classes of fires again, and it's polar as well as non-polar. You know, the D, the Class K, transformer fires, lithium-ion battery fires. You know, our list goes on. Solar panels, all the things that we seem to be, you know, embracing, and all the technologies that we seem to be moving towards to help us, you know, save energy or be green, as we say. We're looking for solutions to stay green, but yet we're not really looking at agents to be able to deal with those types of fires. Here we have a quick introductory video.
Hazard control technology.
When we watch this, one of the things that I point out is that if we look on our screens to the left side, it's going to show that encapsulator agent works on all classes of fires. Okay, so we're not having to carry multiple agents on our apparatus. We look at this fire. I'm going to stop it here for a minute, because here we have a lot of fire. And I mentioned that ability to encapsulate. and reduce those soot and toxins. Here's an example. You still have a lot of heavy fire on these tires. Where's the black smoke? We started to have an effect on reducing that soot and the toxins that are being released by this fire, cleaning up and making it safer. And it does the same when we sit there and start looking at our structure fires. But you see here how it works on being able to do just that. And when you watch these videos, you'll watch video after video where we have chemicals or we have soot, we have smoke that's heavy black because of the materials burning, but yet we're able to quickly and easily remove. When we look at Class B fires, you often get the special application technique. There is no special application technique other than aggressively fight the fire. When you watch videos of firefighters doing extinguishing, here's a good one. He changes his water pattern. You see him open a little bit from spray pattern with power cone, a little bit, but he changes his spray pattern to accomplish what he's doing. He's looking at doing multiple things. Here's that flammable vapors. When I do my trainings, I ask my firefighters in my training courses, can anybody name an agent that they currently use in the fire service that works on flammable vapors? Class C, stored energy, lithium ion batteries. We hear water's the solution, but yet how many times when water's used do we hear about reignition or 30, 40,000 gallons of water, but we didn't put the fire out, you know, it burned itself out. What about all that runoff? Class D metals. Again, about 380 pounds is in an average vehicle. Transformers. As you watch this, you'll see that the transformer is not arcing and sparking. Okay, it has failed. So it's now a Class B fire in a Class C environment. But just a real quick idea of all the different situations that you could safely use this in. And I want to talk about, you know, one other thing here. Let's talk about a tank farm fire. I just threw a little timeline. I kind of got rid of, you know, some of the information as far as where it's at, because it's not so much where it's at. You know, here is a case history, but you know, here this started on March 17th. The year doesn't matter, but you know, at a facility, there are 15 storage tanks. There are 3 rows of 5, and right in the middle of this farm, on a Sunday morning, they ended up having a situation. Okay, now it started on Sunday. Next one goes to Tuesday, and they're talking about the fire, you know, crews. They're switching attack modes to try and get control of the blaze. And it's continuing to, you know, burn. Day 3, and you know, they're starting to have rows, you know, fires. You know, now it's up to 8 tanks that are on fire. Because water and foam is not being effective on dealing with a 3-dimensional fire. Okay, so now we go from the 17th to the 19th, we go to Wednesday, the 20th. The fire was put out for several hours, but I mentioned earlier in the presentation, reducing the heat until we get those tanks down below the auto ignition temperature of the fuel that's still around them. When that foam blanket breaks down, we have everything we need for reignition. And well, later in the day, they were back fighting that blaze again because it had reignited. It goes on now to Thursday, where they're ending up with elevated levels of benzene. They're telling people to shelter in place and closing down schools and campuses and staying there. And then finally on Friday, it was lifted. So when we talk about the benzenes and the encapsulation properties of F500, we could reduce those benzene levels. We can have an effect on those as well. Then Friday, a dike wall partially collapsed because of all the water that had been flown, all the foam that they used through the course of these few days, okay, to try to extinguish this fire. Okay, the dike was not able to contain it all. It failed, and it now released not only the oils and gases that were part of the spill and the benzenes, but also all of that Class B foam, all of that fluorinated foam into the bayou and into a shipping canal. The cause of the fire, a three-dimensional fire. It was caused by a manifold is what they initially believe the cause of this fire was. A fire that even if they, and as you can see for multiple days with foam, they were unable to extinguish, yet encapsulator agent could have been very, very effective. It could have used much less to be able to extinguish this fire and bring it under control, which would have prevented that large spill that caused environmental impact, not only to the bayou, but like I say, as mentioned, into the shipping canal. So we start to look at the advantages of F500 for use as spill control. And while it's not really listed in here, I'm going to give you another case history as I continue on through. But when we look at the principles, being able to apply to hydrocarbon spills, right now we're using kitty litters, we're using other types of absorbent materials. They have to be disposed of. Okay, in most cases, most states, they have to be sent to a disposal site that's approved for these types of chemicals or these types of liquids. And when we understand that the fire department's name or whoever is disposing of those their name gets put on that disposal ticket. So years down the road, if again something happens at that disposal facility, that it leaches out and people start suing and there's class action lawsuits, they start naming everybody that had anything that went into that landfill. Again, hey, you start doing it and start sending these kitty litters and all these absorbent materials off to these landfills, you could end up still being responsible. However, when you look at an encapsulator agent, you saw how it was able to, in that 7.7 test, encapsulate that flammable, making it non-flammable. So if we were to do a washdown using a 3% solution, get the LEL meter out and check to make sure that the LEL, the flammable limits are down to 0, let Mother Nature take over. Let it evaporate away safely, okay, without requiring additional cleanup. Again, minimal amounts of water, depending on the size of the spill. I mean, in some instances, it may not be economical, but in most cases, we look at the form that's 8 parts of the hydrocarbon liquid, and going to vigorously apply that F500 solution to get that 1 to 8 to 40 a mixture, so that we can sit there and we can encapsulate that fuel and render it non-flammable. When we sit there and start looking at these tanker truck fires, and I have, again, being part of hazmat, I've had experience when you sit there and you start dealing with these. You call all of your mutual aid partners, asking them to bring their foam. You're calling your local airport and seeing if they can bring a crash fire rescue truck. And you're trying all of these things to try to extinguish the fire. And finally, after hours, you finally get the fire out. And you're thinking, you did a pretty good job. And then, you sit there and you look at some of the news footage. Maybe there's a helicopter that flew over the scene. You start looking at the videos that they shot. And the only thing that you see is the steel skeleton or the steel frame of that tank truck. Okay, the aluminum tank is melted away. So in actuality, you didn't put that fire out. Okay, it basically burnt itself out. You had little effect. You spalded the concrete multiple inches and closed down multiple lanes of a highway, so that they can be tore up and replaced. How many times have you gone down the highway, just a simple car fire? You can tell where it's burned, especially if it's an asphalt surface. You can tell exactly where car fires have burned up or trucks have burned up on the highway when you're going down, because we're not able to be effectively cool and extinguish these types of fires and bring these LELs to a safe level and keep them that way. And I also talk to my firefighters about auto accidents where there's a fuel spill and you need to extricate a person. How are you currently doing it safely? I know you're pulling hand lines. I'm not sure if you're putting down, absorbent materials or what, but how better a way to make that scene safe than to use an encapsulator agent? Encapsulate the fuels, monitor, make sure that no fuels are continuing to leak. Watch that LEL. As long as that LEL is staying at 0, you can safely get those victims out of the car. There's no blanket that you have to worry about maintaining because we've encapsulated the fuel. We're working on that chemical basis, not on the mechanical basis. So I mentioned earlier, and I'll mention again, the cleanup. You leave it on a hard surface, let it evaporate away, depending on local regulations, but we are listed on the EPA's National Contingency Plan as a surface washing agent. When you sit there and start looking at applying foams, again, they do nothing to really alter the properties of the fuel. The hazard's still there. So now not only are you worrying and having to clean up the gasoline that was spilled, but you're now also having to clean up that foam that you use to suppress the vapors, or again, those absorbent materials. When we look at the requirements for applying foam, we need to start looking at our discharge times. Okay, the minimum discharge times when we're dealing with, and you look in the foam standard, it's 15 minutes. If you're sitting there and you're on a flat spill, and you're going to apply foam, let's again take into account that auto accident, you're going to be applying for 15 minutes on that spill, and then you have to maintain that blanket. And if you start having people walking through it, doing their extrication of victims from a vehicle, you need to constantly be reapplying it. So the amount of concentrate that you could end up using could be rather costly. So we'll take a quick look at it. And let's just take, for instance, a spill. We're going to use an 8-gallon amount as a guideline for this particular slide. And it's going to show how, again, if we think of the formula, 1 part of F500, 8 parts of fuel, 40 parts of water. Okay, so we have an 8-gallon spill, which means we're going to need 1 gallon of F500 and 40 gallons of water. Yet, we look at the guidelines and requirements for foam, we need to apply for 15 minutes. Okay, and we need to maintain it. So we may have to do multiple applications. So, but just at minimum for the 15 minutes, we've used 36 gallons of concentrate. And we've created a mess that we now have to pay to get rid of. So instead of being able to mitigate this with 1 gallon of a concentrate and be done with it, let Mother Nature evaporate it away, we've now created a huge mess because now we've got 36 gallons of foam, concentrate in the water. We've got the 1,200 gallons of water. We've got still got the 8 gallons of fuel, and you are going to have to pay somebody to clean it up. And I mentioned, if this is on private property, what's going to happen as far as down the road if that ground is contaminated and somebody may want to sell. So the neutralization, when we look at a foam, is temporary. When we sit there and we start looking at the encapsulation using F500, we're going to sit there, we're going to encapsulate it, and it's going to evaporate off. I said before that I was going to kind of throw out there a little bit of a case history that is I was informed of, and I've written up here, and hopefully will be part of presentations later on. But there was an incident at an airport where a gentleman was filling an underground storage tank, and he connected to the wrong tank, and there was somewhere in the area of 3,400 to 4,000 gallons of jet fuel that was overfilled, because as the jet fuel started to shoot out of the vent pipes, the operator of the tank truck, he panicked, and instead of shutting things down, he kind of ran off and let things go. So that's why we had somewhere in the area of, like say, 3,400 to 4,000 gallons of jet fuel. About little less than 300 yards away from this spill was where the tower was for the airport. And the spill went out onto the tarmac, was on top of the roof of this pump house where the vent pipes and everything were, and then in the grassy area where the storage tanks were. So again, being an airport, crash fire rescue trucks came out. They started to apply the mil-spec foam. Because of the heat of the day, they had to continually reapply about every 6 to 7 minutes because the bubbles were breaking down and evaporating off that quickly. And the local utility company has trailers that carry 500 gallons of F500 concentrate. And luckily, a few weeks before this incident took place, I had done some training with the fire department that was in the jurisdiction of this particular airport. So when they were called in for mutual aid to the airport, they were familiar with the fact that this utility company had these trailers, so they made a call for one. The trailer arrived and they started to treat all the areas that were affected by this spill with the F500. They let it set for about 20 minutes, and at the end of 20 minutes, they started walking the area with LEL monitors, checking the roof, all the areas that were affected, all the areas that were of concern, the major areas of concern. When they checked all these areas and found that they had 0 LEL. So the IC, the officer in charge of the scene, said, you know what, this seems to be safe. Send everybody home for the night. In the morning, we'll call in a cleanup contractor and we'll get the rest of this mitigated, get this cleaned up and get the ground taken care of. So the next morning, cleanup contractor arrived. They start walking the area with their LEL monitors and kind of like shrug their shoulders and throw their hands up in the air and just, where do you want us to dig? Where was the spill? So they kind of pointed to an area and they said, well, dig over here. So they dug a spot out that was about 2 inches deep and it was 10 by 20 feet in length, and did some monitoring and said, well, what do you want us to do now? So they pointed to another area and they say, well, try digging over here. So I dug over there, and this time they went a little smaller. This one was maybe a 5 by 10 little area that they dug up, and they only went down maybe about an inch or so. Again, did their monitors and testing, and I said, hey, what do you want us to do? So actually they did nothing. The cleanup contractor was on scene for about an hour, maybe less. I'm told that it probably took them more time to get their equipment on and off the trucks than it did to actually do any of the remediation. But again, it just shows you that, you know, they use the F500. The F500 was very effective. It knocked down those vapors, knocked down the LEL, and it helped begin breaking down and mitigating that scene and reduce the cleanup cost immensely. So when we sit there, we follow that, you know, that guideline.
In this segment, we're going to show the F500's capability.
And again, they're showing, you know, when we sit there, we start doing that fuel encapsulation. Okay, making that formula. This is, again, that 7-7 test. Okay, we're taking a gallon of gasoline, the 16 ounces of a concentrate. We've mixed it. We've got that solution. We got that 1-840. You can see in this particular video the motion of those micelles working to maintain and keep the encapsulation. We're getting that LEL monitor out, checking the LEL to make sure that it's reading at 0. And we take that encapsulated gasoline, and we're going to sit there and have it thrown on top of those tires. And as you can see, the encapsulated gasoline is quickly and easily able to extinguish those tires. Again, the formula was that 1-8 party, the 2.5%. But with our eductors, deducting at 3%, we do have that safety margin. We see in this video, again, a fuel spill, that gasoline that we saw maybe earlier at the gas station where they're using an absorbent on, and I started talking about, being able to wash it down. Auto accident where there's a fuel spill and the fire department needs to do an extrication. We see that we've encapsulated one side of the fuel, and when we lit it up, it did not go across from the side that was just gasoline to the side that had been encapsulated. They come back, they continue to do the washdown. Now, instead of an LEL monitor, they're gonna walk through there with a torch. And you'll see as he walks through, he's gonna stop here in just a second. He's gonna kind of sweep his foot across to show that there's no foam blanket, there's nothing to break, there's no vapors. And now he continues to go across there and show that that has been encapsulated. It's no longer a hazard. Mother Nature is your cleanup. So we use much less than we do when we try to use foam. Again, using foam or putting that blanket on the surface, we're still having to clean that up. And that cleanup cost may come back and bite us years down the road. So we look at the use of an encapsulator agent and Mother Nature evaporating it off. We talked about that spill with the gas, with the jet fuel at the airport and the mitigation process, the F500 being able to have an effect in helping to break it down. So much less water, as far as less stiking, because you're not using as much water to be able to extinguish these types of fires. The fines that you would get from the runoff, especially if you're in an area where they have storm sewers and other things that now they have to deal with and try and get these solutions out of, to again make the storm sewers safer. So your cleanup costs are greatly reduced. And not only that, but let's look at some of the other things. If we're on scene for hours and hours and hours because we need to continually reapply the foam and maintain a blanket, okay, and we're instead using an encapsulator agent and we're encapsulating that fuel and let it evaporate away, we have less wear and tear on our firefighters, less fatigue. What are some of the main causes of firefighter injuries on a fire ground? Okay, stress, fatigue, tired, okay, less wear and tear on equipment. Let's look at cost of diesel fuel for the apparatus, our trucks now. So if instead of being on scene for 4, 5, 6 hours, we can be on scene for an hour and a half, how much less diesel fuel have you just used? What is your savings? Okay, so there's many benefits to using an encapsulator agent when it comes to dealing with these spills, when it comes to being able to mitigate and to take care of these types of spills. So, we talked about, those class B and D, and, we can actually throw in here because, in Chile, we had instances where F500 was used in the hazmat to mitigate a sulfuric acid spill. So there's benefits in other applications as well. But when it comes to those 2-dimensional and 3-dimensional class B fires, we can also now even look at our fixed systems, okay, where we have sprinklers. I mean, how many times in the last, I'm going to say, well, I could probably cut it down to like the last 3 months, 2 months even. We had a Walmart distribution center. We just had a couple of Home Depots that had fire. I mean, we keep hearing and reading and seeing about how these systems, these fixed systems in our buildings, okay, while they activate, they're not really doing much. We were still losing buildings. We're still losing millions and millions of dollars because these systems aren't being able to extinguish the fires. But now if we again think and start adding an encapsulator agent into the water using our concentrate control system or our water driven proportioners, our diamond dosers, I mean, these could be used to feed multiple risers, protect multiple areas of a facility, a warehouse, a refinery. Again, when we sit there and look at vapor mitigation, vapor control to prevent fires and explosions from even occurring. I mentioned earlier in the presentation can anybody name for me an agent that they have in the fire service or on their apparatus that works to control or eliminate flammable vapors and prevent these types of explosions? I now, after this presentation, you now have that tool in your toolbox. If you sit there and you start to embrace and learn about encapsulator agent, we can sit there and we can help you with those types of situations as well. So with the equipment, like, 2.5 gallon pressurized water cans or the 6 liters. We have what we call our quick attack mobile units that come in various sizes from 25 up to 100 liters. Our portable carts you see is the yellow ones, compressed air systems and so on. But then there's also, like I say, mobile response trailers. I mentioned the one utility company. They have 3, and I believe they're getting ready to order 3 more. Again, they have them scattered around the state where they have their facilities, and they make their trailers available to the fire department. In fact, in most cases, these mobile trailers are stored at fire stations so that they're right there and ready to go. So we talked about all the different apparatus and ways that we can get you into the sprinkler systems and help you out. Some of the other areas are consulting and training. While we basically, show you the coal side, the hazard analysis, the emergency response planning, we're also available if you sit there and start looking at lithium ion battery, fire protection for BESS system, battery energy storage systems. We can help and consult and train. I know when I watch a Tesla burn up and you watch the interview with the firefighters, one of the first things they talk about is we need more training on lithium ion batteries. Well, you know what? Let HCT help you. More than happy to work with you in getting some training and sharing with you the reports and the things that we've learned on how F500 is able to work, because again, it ties into that flammable liquid. Okay, the electrolytes that are in those batteries are a flammable liquid. One of the reasons why water is a failure is because it doesn't do anything to eliminate that electrical hazard or that flammable hazard. Okay, F500 does. We encapsulate the flammable liquid in the electrolytes, so we can have an effect as well as reducing the HF gas that those batteries release. So we work in many different applications, and I know all this was supposed to be based on our spills and things like that. I went off and maybe covered a little bit more than that, but again, I said early on, I was hoping to make firefighting a safer profession. So through this, I wanted to make sure I covered a little bit of everything, as well as that flammable spill control and environmental issues. And with that, I would like to say thank you for your time and listening and being present, and would gladly open up the floor for any questions that we might be able to help with an answer.